Okay, in our second half of our look at section 3.2 in the study guide, we want to focus a little bit more on a graphical approach to slope, and then also the idea of slopes for parallel and perpendicular lines. Okay. So let's look at the graph here. We have a whole bunch of lines all over the place in here, so we'll try to use some colors to bring to life what we're actually looking at. So I want to find the slope of each line, but I'm not going to use my slope formula. What I'm going to do is just count the slope off in the picture. So for example, if I want to move from A to B, okay, how would I go about doing that, right? How would I direct somebody to get from point A to point B? So at point A, remember, we always are going to go left to right. So I'm going to start at point A and move to B, not the other way around. Okay, I won't go from B and go backwards. Always find the point that is to the left and move to your right, just like you were reading a book. You read your books left to right. So I'm going to start down here at this point, and I'm going, in order to get to B, I'm going to have to go up first. So this is going to be a positive slope. We're going to go up 1, 2, 3, 4, 5, 6, and then I'm going to go over 1, 2. So that is a slope of 6 over 2. We want to simplify that to 3 over 1, or just simply 3. Okay? Let's try the same thing for CD. And we're going to answer some of these in the Ed puzzle as well. So let's look at where C is. He lives right here. And where D is, below him. So again, we're going to move left to right. So we have to start at C, not just because it's listed first, but because it's the leftmost point. In order to get from C to D, I'm going to have to go down first. So this is going to have to be a negative slope. So I'm going to go down 1, 2, 3, 4, and over 2. So I went down 4 and over 2, or negative 2 over 1, or just simply negative 2 is how you'll see that slope written a lot of times. Okay, now let's try EM. Okay, how do we move from E to M? Well, from E to M, we don't move left or right at all. In fact, this is a vertical line. So if you remember, the slope of a vertical line is undefined. Okay, they both have the same x coordinates, so that would be a 0 in the denominator if we plugged into our slope formula. So that slope is undefined. Okay, how about from A to E? This is the exact opposite, or at least perpendicular to the previous line. It's not vertical, it's horizontal. In other words, this time there's no change in the y coordinates. They're both negative 2, so we would have a 0 in the numerator. So this is just simply 0. It's not undefined. We have a slope, but it has a value of 0. From E to H. So even though they list E first, H is the leftmost point. So in order to move from left to right, I'm going to start at H and move to E. Even though that says EH, start at H and go to E. So in order to get from H to E, we're going to have to go up. So this will be a positive slope. So I go up 1, 2, and then I'm going to go over 1, 2, 3, 4, 5. So that's a slope of 2/5. Okay. And then finally the last one, BM. How do we move from B to M? We will start at B because it's further to the left, and we can see we're going to have to go down, so this is going to be a negative slope. How much do I go down? 1, 2, and then I go over 1, 2, 3, 4. So that would be a slope of negative 2 over 4, or negative 1/2. Okay, so you have your graphical approach to slope. Now we want to revisit this idea of parallel and perpendicular. Okay, so remember, if two lines are parallel, they have the same slope. Okay, parallel lines have the same slope. Two lines are perpendicular, their product of their slopes is -1. In other words, they're opposite reciprocals of each other. Easier way to say it. So what we mean by that would be like if we have 2/3, the slope perpendicular to that would be -3/2, because if I multiply these two, I get a product of -1. Okay, so the one thing I felt like we were missing the other day in the Go formative discussion is that not only do the fractions flip, but the sign has to change as well. Okay, so here we want to answer the question: are MN and RS parallel, perpendicular, or neither? So the way I'm going to set this up is I'm just going to look at those two slopes side by side. I'll look at the slope of MN and the slope of RS, and we'll compare them directly. The slope of MN is going to be 3 minus 4, right? I subtract And then in the denominator, we subtract the x's, which would be 0 minus 2. So I get negative 1 over negative 2, which is positive 1/2. So in order for them to be parallel, the slope of RS would have to be 1/2. In order for them to be perpendicular, the slope of RS would have to be negative 2. So let's see what the slope of RS is. 1 minus 4, right? We subtract the 2 y's in the top, over 2 minus 8. So I have negative 3 over negative 6, which would simplify to positive 1/2. So our answer here is that these two lines would be parallel. Okay? Now we try MN and RS again. Slope of MN, we take 3 minus 5. And then divide by negative 1 minus 0, right? 3 minus 5 over negative 1 minus 0. I get negative 2 over negative 1, which is just 2 over 1. I'm going to leave it as 2 over 1 so that we can compare it to a negative 1/2 if we have a perpendicular situation over here. So for RS, we're going to take 1 minus negative 1, right? 1 minus negative 1, those are my two y coordinates, over 2 minus 6. So this is really 1 plus 1, which is 2. This is 2 minus 6, which is negative 4, or negative 1/2. So it looks like we have opposite reciprocals of each other, or negative reciprocals, so these would be perpendicular. Okay, so I think sometimes people get confused if they see 2 and negative 1/2, so I leave it as 2 over 1, and then you can clearly see that those are negative reciprocals of each other. Okay, so same thing again, we're going to compare directly, side by side, right next to each other, MN and RS. So my whiteboard's not cooperating with me here, being very contrary. So let's see. MN and RS again. Compare the slopes side by side. MN, we have 3 minus 4 in the top. In the denominator, negative 1 minus 4. So this would be negative 1 over negative 5, which is 1/5. Okay. RS, 1 minus 2 in the numerator, over 3 minus negative 2. So this is negative 1 over 5. So not quite. We have, they're opposites of each other, 1/5 and negative 1/5, but they are neither. They're not parallel, because one is a positive slope, one's a negative slope, but they're also not perpendicular. Okay, here we want MN, and then we'll do RS. So we have negative 3 minus negative 7, which would really be negative 3 plus 7. Then we have 0 minus negative 2. We got to watch these positives and negatives. So this is really negative 3 plus 7, which is 4, and this is really 2, or 2 over 1. I'll leave it as such. And now RS, 1 minus negative 3, okay, over 2 minus 0. So this is really 1 plus 3, which is 4, over 2, which is 2 over 1. So here we have a situation where they're parallel. Now, an interesting case that we didn't come across here would be a situation where we have a vertical line where the slope is undefined and a horizontal line where the slope is 0. They would be perpendicular. Okay, so that, keep in mind, if you have a slope of 0, that would be perpendicular to an undefined slope, because you would take that 0 and put it in the denominator. All right, and then finally, our last example here is going to lean heavily on the look of the graph here. I'm going to take each of the situations that are described here and graph them. So I want a slope of 4 and passing through 6, 2. So I'm going to go draw that point at 6, 2 first. That's probably the easiest thing I can do. 1, 2, 3, 4, 5, 6, and then up 2. And now I want to also have a slope of 4. So how would I get to my next point from this point at 6, 2? I would go up 1. I'm going to go up 1, 2, 3, 4, and over 1. And then I would connect those 2 points. And that's my line. Okay. Not the straightest of lines that I've graphed, but it's there. Now we want to pass through 8, 5. I can find that. 1, 2. Go out to 8, 5. and plot the point. Eight. 1, 2, 3, 4, 5. Now, what's interesting here is they give us it's perpendicular to a particular line. So we might have to go backwards in order to find the next point. Otherwise, we're probably going to have to go off the graph. So we have to go through that point at 8, 5. And now let's think about what the slope looks like. We're going to take 6 minus negative 2 and divide that by negative 5 minus negative 1. A lot of negative numbers here. So 6 minus negative 2 is really 6 plus 2. That's 8. Negative 5 minus negative 1 is really negative 5 plus 1, which would be negative 4. So my slope is going to be, it's going to be a slope of negative 2, right? This is negative 2 over 1. So I actually think I can fit that here on the graph. So from this point at 8, 5, how would I tack off a slope of negative 2? I would go down 2 and over 1. And that's my line. Okay. And the last one, we want it to pass through negative 2, 5. If it's okay, I'm going to just go ahead and draw it on this graph here. If you're taking notes, you can draw it on the one down below, but I just want to keep the problem on my workspace here. This one is going to pass through negative 2, 5, which goes off of my paper here. Negative 2, positive 5. So we'll just go off just a little bit. It's only one square off. And it's going to be parallel to the line LB with the points 2, 1, 7, 4. So the slope of LB is going to be the slope of our line. They're parallel to each other. So we have 1 minus 4, okay, over 2 minus 7. So this is negative 3 over negative 5, okay, which is 3/5. So this second point is also going to have to go off of our graph here. We're going to go up 3 and over 5 from here. So if I go up 3 from here, I go up 1, 2, and I'm just off again, 3. And then we're going to go over 5. So 1, 2, 3, 4, 5. So not the best graph paper to do that one on because it goes off. But that's where that line would live, kind of lives off of the graph that we actually have.